And we should be on. So, good morning, evening, everybody. Welcome to the Core meeting 79. I'll share the agenda in the chat, but we have a whole lot to cover today. Um, First item that was on the agenda was ungas, so I wanted to try and prioritize that with regards to time, just based on the conversations in the chat before. But Wei is not on, so is that a conversation we can have without Wei, or should we try and wait for him to show up?
I I can probably because we cannot go very deep into the technical details anyway. I would be able to answer probably most questions, and I also will explain what the last thing that Wei was saying about how it's related to the account versioning EIP for Berlin. Like for example, he said that he wants to withdraw
Sure.
it from Berlin and push it to the. So do you want me to start to explain a little bit
Yeah,
quickly? Why
yeah,
is
I
it
think that's
related to
helpful.
stateless Ethereum? And okay, so gas was introduced a while ago by Wei, but I didn't understand it at first, and I guess probably a lot of people also did not
Sure.
understand how could possibly help us and how it could possibly work.
Yeah,
But
yeah, I
then
think that's helpful.
when we started the conversation, and he explained it in conjunction with other things like account versioning and repricing of the opcodes. So if you look at these three things together, then it starts making sense because on its own, or any of these three things on their own, ungas, account versioning, and repricing, they basically kind of, they cannot, they don't really have a lot of merit on their own. But if you put them together, then it actually starts making sense. And then we discovered that ungas might be something which will help us to make the stateless Ethereum gas repricing easier. And at the last stateless Ethereum call, thanks to Martin, we realized that we might be able to not reprice any specific opcodes to accommodate for stateless Ethereum, but instead simply uh, sort of meter the gas which is used for the witness itself. So which will be much more, I would say, much better design because it has the proper separation of concerns. So in short, the ungas proposal itself is the suggestion to remove the ability for smart contracts or any EVM code to observe the notion of gas entirely, and which is currently possible through three different mechanisms. Maybe there's more, but we didn't discover any more yet. So the first mechanism is the opcode gas, which puts on a stack the amount of gas remaining in the current whatever frame. So the second mechanism is where you, when you do the call or call-like instructions, you can specify how much gas is forwarded to the next call. So this is where another point where you observe it. And the third point of observation is when you hit the out of gas exception. What happens is that in current EVM semantics, the it causes the current execution frame to revert and essentially cancel all the state changes, but it does not revert the frame which is called this current frame. So essentially, by doing this, somebody could observe the gas, but it might not be very useful. But anyway, so what Wei is proposing with ungas essentially three main changes. First is to disable the instruction gas. Secondly, to not to stop the call-like instructions from forwarding the gas, and the behavior should be to forward the entire gas all the time. And the third change is essentially to change the semantics of out of gas exception so that instead of reverting the current frame, it would revert all the frames and essentially revert the entire transaction. So the entire transaction immediately fails upon the out of gas exception. So these three changes, I probably won't be able to debate like the technical merits of all of this, but maybe we could use this just to sort of warm up so everybody can research on their own and sort of sink into this idea. And now I'm going to explain why it makes sense to view all three changes together. So uh, essentially, this particular change in EVM is very disruptive. Like you, essentially, if you try to implement it as it is, it will break pretty much everything, like this particular semantic changes. And therefore, Way is proposing to roll it out together with the account versioning. But the account versioning, not in the sense that we're going to have increasingly many account versions, but we will only ever have two versions and no more. There will be one version which is before the ungas, which he calls legacy version, and the second version which after ungas, and that's it. There will be only two versions. So essentially, it's like a bit which will be marking which one of this. So as you can imagine, in the legacy version, the semantics doesn't change. Everything works as it works now. Gas is observable. Everything is okay. In the future version, which is introduced together with the ungas, essentially the rules of ungas apply. And also, the way that account versioning is proposed, the code which is deployed, so the contracts which are deployed from a legacy code, using, for example, some sort of factories, they will also inherit the legacy flag and therefore will also be using legacy rules. So everybody can probably notice that this is the way to potentially completely circumvent the new version. So you can easily leave out the very generic proxy and just keep creating contracts through it after the ungas is introduced. So how does this get addressed? So this is where the third change comes in, is repricing. So what is Way is suggesting is that once we've introduced the second version, initially it probably be very little use. But then after that, we start repricing opcodes, but not in a way that we just to choose one opcode and reprice it, like make it more expensive or make it less expensive. But instead, we're essentially repricing everything across the board. And if we needed to, let's say that example is EIP 1884, which is essentially increasing the gas of certain opcodes. If we had to do the similar change again, instead of doing what we did in EIP 1884, we instead leave the gas of those operations intact, and then we'll simply reduce everything else. And and that means that the um, the legacy contracts will see their operations being more expensive. Essentially, if you do it if you do it enough, the legacy contracts will be priced out, and they will eventually be forced to redeploy. But in a way, it's kind of economic measure rather than like I'm going to break your contract measure. And the reason why it will work is because the miners could potentially like look at the different transactions and trying to figure out which one using legacy code, which is not, and apply discriminatory gas prices. Let's say like, oh, if it's a legacy one, I will apply cheaper, like a small gas price. If it's the future one, I'm going to apply um, the big one. But in general case, it will be impossible to predict whether the certain transaction will touch both of them or only one of them, and so forth. We think that the miners will not be able to do that in general case. So they will not be able to distinguish them, and they just apply the uniform gas price. And then, of course, it raises the questions like how are we going to reduce the gas cost of the operations which are already like two gas? And this is where we have two alternatives: is the particle gas cost, and Way has its own proposal, which he thinks is simpler. Is essentially idea is that when you do the call instruction, you artificially bump the gas, available gas, like times 10 or something. And then when you return from the call, you reduce it again. So you create the illusion that the everything is actually cheaper. But this is basically the summary. And in a stateless Ethereum, if we wanted the reason why it would help us is that we will be able to meter the witness size separately from everything else. So we will leave the all the opcodes untouched with their gas price and semantics. But when we charge for the size of the witness, we will introduce a separate counter, which will only count like how big is the current witness, and so we will apply um, the out of gas exception in a case where either it's either the execution basically consumed the entire gas, or it's the witness that consumed the entire gas. I haven't worked out all the details, but I think it will greatly simplify the design, and it will help us not to basically mix everything together. So that's my summary. And as I mentioned that way during the Open Ethereum workshop, so he had a little presentation on Wednesday when he was describing which AIPs are currently kind of already sort of accepted for, well, not accepted, but proposed or pre-selected for the next hard fork, and that includes account versioning. It's 1702. So he mentioned that his intention is to withdraw it, but so that it could be included into the later releases together with ungas. And I think the particle gas might also need to be kind of withdrawn and re-included, but it's up to the authors to do that. So that's it for me.
I have a few questions.
Hmm.
So you dropped one of these notions that essentially account versioning would only ever entail two versions.
Yes,
I
that
mean,
was the plan. Hmm.
I mean, the fact that we're introducing a second version means that if Ethereum stays around indefinitely, then we're going to introduce indefinite versions eventually.
Um, no, we basically the idea is that we will only use the account versioning only for one purpose, is to distinguish between ungassed and non-ungassed.
Well, yeah, but if you introduce an account version to distinguish between these two concepts, why can't you see it possible that we will introduce yet a third concept which needs differentiation?
Potentially, yes, but it's not at the moment we don't envisage this, but I'm happy to try to explore this, whether this is going to be like too tempting to not to do it. But so I think the reason why Wei specifically said that, because one of the criticism of account versioning was that, oh, but we're going to end up like with 100 different versions that we have to all support. So which is a very valid criticism. We don't want to do that, and we're going to keep all this functionality forever. That's why he decided to shrink his account versioning proposal to like shrink the scope to only distinguish between these two things. And well, we could talk about the what it might be in the future. I think you have a very valid point. It wasn't an intention though.
Hmm. Yeah, okay. Either way, this was just one of those nitpicks.
Yeah.
A more serious question, though, is so currently, let's suppose we roll this whole ungas out with account
Hmm.
version, and then
Hmm.
we have version 1 and version 2 contracts. Now, an interesting thing happens when these contracts start to cross call each other.
Yes. Hmm.
So, for example, um, maybe this is not even a cross call, maybe it is just a version 2 call. So, if you were saying that if I call another contract, then everything gets forwarded, all the gas.
Yes, in the new version. Yes, correct.
Okay, but
Uh-huh.
this kind of means that if I'm writing a contract so if I'm writing the host contract, the origin contract that will call out to something else,
Hmm.
then how can I make sure that if that something else has a bug or is messed up or whatever, then I can still finish running? Because if you, for example, I uh, I create a contract that depends on something else, and that something else gets deleted, or or not,
Okay.
maybe goes into an infinite loop, whatever it is,
Okay.
bug, then
Uh-huh.
that contract will never actually succeed. So no matter what I do, it will always throw out of gas, which means that
Okay.
any other contract which calls it will always fail too, because since you forward all the gas, it will nuke everything out.
Yes, and it will also always terminate the entire transaction. Yeah. It's useful to include it into the. So let me just write it down because I don't think I will be able to answer this now, but I will include it into the questions too for discussion.
Okay, and just you actually reminded me what my more complicated scenario was. You are saying that when we run out of gas in this version 2 call, then we
Hmm.
revert the entire transaction.
Yes.
But what happens if a version 1 contract calls a version 2 thing which goes out of gas?
Um, so I'm not sure, but I think the idea was that if you are in version one and you call in version two, then it's probably still has the rules of version one. I'm not sure actually. So it's a good question. So let me write it down as well. So, and
Mhm.
this actually, your questions are good because what I currently disagree with way on is my kind of intuition tells me that this is a really complex change, although it doesn't might not look like this. So essentially, in terms of the very like in tiny issues with semantics and like what you just gave two examples of the things that really they could be like really cans of worms. So that's why it's actually probably what I would say is that it's the most complicated things that we have ever done if we do it right. Anything else was like really simple compared to this. um, that's why I thought for a long time that the prerequisite for this change is actually to some kind of formal semantics, and this is what I'm currently starting to work on, and so that we can analyze this really rigorously, because the chances that something is not getting covered are very high here in this particular change, because it doesn't look like the description is very short, but actually it's very complex. Um, so let me write it down, these two questions to you, and I will, create a. I will. I don't know. Like I probably will discuss it with Wei, and he might update the documentation based on that.
Okay, and by the way, the other way around is also interesting. What happens if version 2 calls version 1? Because now from a so you had this idea that if you start out in version 1, then everything runs in version 1.
Yeah.
That's okay, but what happens if I do the other way around? Now, if I start out with version 2 and everything runs in version 2, this means that if you reprice version 1, all that really
Yeah.
will be moot because I can just create this version
Exactly.
point which just forwards the call.
Exactly. So if there is a hard rule that like any transaction either runs version one or version two, then the argument about repricing doesn't work anymore because miners could very easily distinguish what is going on, and they can apply different gas prices. I completely agree with that. So the repricing doesn't work if the cross version calls are not allowed. Um, yeah.
So,
I'm sorry,
go on.
I'm also curious about things like delegate call.
So the delegate call will, according to the description, the delegate call will also have the same behavior. They will forward the entire gas.
Right. But if I one type of contract and I delegate call, that is I'm temporarily using the code from another contract. Does it
Yeah.
matter if that other contract is version one or version two?
Okay, that's also a good question.
Or does it only matter what I am?
Okay.
Well, actually, if I start out as hmm,
So I think you guys started to open. This is really good because you actually started to open that kind of worms, and worms are coming out at the moment. So, and I think it's really good because we're gonna have either have to clarify it or just sort of rethink this. I wrote down the three questions so far. So clarification between cross calls of contract, what happens and what happens with out of gas when version one called version two and backwards, and what happens with the delegate call. I think once we clarified what happens in these cases, we can have a more detailed discussion because I'm sure we can dig deeper into this. Okay.
I had one question about
Mm-hmm.
the stateless Ethereum side. If it doesn't, the version, if it works as Wei describes, and you can have that separation of that doesn't break a lot of things. then do we still get what we need for stateless Ethereum, like the benefit out of it, or does the backwards incompatibility kind of remove that part?
So if the separation of the versions does not work, and that simply means that account versioning isn't going to work at all. I mean, it means that everybody will probably be using the version 1, and there's nothing you can do about it. You will basically have to design the entire like stateless Ethereum on the premise that everybody is still going to be using version 1. So you will not gonna get any of the benefits of sort of so essentially the plan was with the ungas, the reason why it would help, because if we start to economically kind of push out the version 1, and we know that the usage become so let's say negligible, then for the purposes of pricing the witness, we can simply ignore anything that happens with version 1 because it's going to be super expensive, and we design our pricing logic based on version 2. So if we know that, okay, the version 1 pays so much that it will definitely cover any kind of witness that will arise, and version 2, we know that we can do ungassed, that's why we can price it more correctly. However, if the version separation doesn't work out and we cannot price things out, then it means that this logic is not going to apply anymore, and we have to design based on version 1, which is basically where we lost all the benefits. I hope that I explained it clearly enough.
Yep, yeah, that helps.
Okay.
And I also like the moving it out of Berlin so we have more time, because is anything that would have to be coordinated with contract code is just going to take would be better to have a lot of time to discuss.
Yeah, the reason why the account version was pushed out of Istanbul because we realized it's not useful yet, and I think on its own in Berlin it's also not useful yet. So there is nothing that requires it. But if we have something which actually depends on it critically, then it could be done.
Yeah, so the reason why I would also say that account versioning is fine as long as there's actually something using it, because otherwise we kind of run the risk of introducing some semantics which nothing uses but make everything down the line more complicated. So.
Yeah, thanks a lot, Alexei, for the background on this. I think it's really helpful to get everyone up to speed. And
can I just add one?
Oh, sorry. Go ahead. Yes.
Yeah, can I? Alex, I'm very interested in the stateless client centered Ethereum part, and I'm clearly not familiar with the ungas. Would you be able to publish pointers for other people to learn about the topic, and maybe a print like somewhere a link towards a way presentation?
The presentation, you mean the one that I mentioned?
Yes, please. Yeah.
So the one he mentioned wasn't actually telling a lot about ungas. It was simply going through the EIPs in Berlin and essentially saying which one are already implemented in parity and which one are easy to implement. Essentially, the conclusion was that like if so all the Berlin changes could be implemented in parity or whatever you call it, Open Ethereum, without major re-architecture. So it actually could be done in like a low resource mode. And there wasn't really a lot of information about ungas at all. So I would rather actually do something separate for that.
Please do.
Yeah, but
I'm
the
just.
spec is linked from the agenda.
Yeah, there isn't things on agenda which describes the. So if you go to the agenda for this meeting, so when Peter asked, like, do you have any links? So after that, somebody posted a link to the Waze description of this. Yeah.
Yeah, that's probably the best place. I don't know if there's an ETH Magicians thread that discusses this, because I think Waze resource is kind of a I guess blog post is a bit underselling it.
Yeah, but I expect we will get onto it in our ETH1 research group. We're just basically getting started. Cool. Like we haven't gone that far yet, but just be a little bit of patience, and I think we will start creating resources on that.
Great.
Thanks.
Anything else on ungas? Okay.
I would say, Yeah, I would say that we should make the ungas and those proposals still as EFI, but also just note, like just as a motion of order, that it is unlikely for targeting Berlin, like those changes.
Yeah, I think the challenge with ungas.
Pretty much out.
So yeah, it's out of Berlin, and I don't think ungas actually has an EAP. So I think Way wrote it down sort of on his website, but I don't think it's been made into a proper EAP. So we probably need.
No, it's definitely unspecified, and from my personal opinion, it can only be properly specified with some sort of formalization, because otherwise it's never going to be formal enough.
Got it. So yeah, I guess we probably just want to keep this, at top of mind, but I'm not sure, James, if there's like something we can actually put in EFI.
So what I would say that I don't know what EFI is, by the way. Is it like eligible for inclusion?
Yeah, it's
Yes.
the new.
Okay, so yeah, I
pre-accepted.
suggest that at this moment we are like not there, and we will go into refining specification, like, because as I said, we're just opening a can of worms, and we need to address all the questions and everything. And whenever we have some new information, we'll present it. If we don't have any new information, we will probably just keep researching, right?
Yeah, that makes sense. Great. Moving on, just because we've already sort of a third of the call in. Next thing to be discussed was EAP 2464, which is around the EAT 65 protocol. I think this was yours, Peter.
Yep. So a quick TLDR. Essentially, this EIP is about making transaction propagation more optimal in the network. I'm not sure how many of you implemented networking protocols here in Ethereum, but when you are propagating blocks, the way block propagation works is that we have 25 to 50 peers depending on client. And whenever you receive a new block, you send that block in its entirety to, I don't know, 4, 5, 6, 7 of your peers. And you just announce it to the rest. And the reason why this is good is because if a block has 50 kilobytes, then sending it to only a small number of your peers is enough to propagate it through the network as long as the network is healthy. But if there are some degenerate topology links, so for example, if you have a small subnetwork that's behind a firewall and there's only one gateway connecting it into the main Ethereum network, then it can happen that that link doesn't get chosen to be sent, for the whole entire block to be sent over. And then by also announcing it, we ensure that if we, for some reason, didn't propagate it to somebody, then we still announce it and that somebody can retrieve it from us. And this is nice because it means that if we have 50 peers, then we send the block to 7 of them, and which, I don't know, is a few hundred kilobytes of data. And for all the rest, we just send a 32-byte or give or take announcement that, hey, there's a new block with this hash. If you want it, come get it. And then usually clients, what they do is whenever they get a block announcement, they wait about half a second. And if the block doesn't arrive from any other peer, then they actually go and retrieve it. Now, this is how block propagation works. It works really well. We can probably make some minor optimizations, but it's fine. Now, if you look at the network bandwidth usage of Ethereum, you'll see that there's actually a huge chatter in the network. And this huge chatter is caused by transaction propagation. Now, opposed to block propagation, transactions don't have support for announcing a transaction or requesting a transaction. So essentially, the only way nodes can learn of transactions is if somebody pushes it to them. And this is problematic because you cannot do this same trick as you did with blocks, where we just send the new transactions to some of our peers and let the others discover it, because there's no way for them to request it. And there's no way for us to announce it that, hey, there's a transaction with a given hash, come get it if you want it. And this causes the bandwidth usage of Ethereum to be kind of huge. So I know our boot nodes, for example, are doing around, let me check a number, around 1 megabyte per second. They are doing 1 megabyte per second download, upload, just to shuffle the transactions. And there's absolutely no point. So the way currently it's implemented is that since there's no announcement mechanism and no retrieval mechanism, we just send the transaction to everybody. So if I have 500 peers, then I will send that single transaction to 500 different places. The problem is that if I have 500 peers, I will also receive the same transaction from 500 different places. So it's a huge waste of bandwidth. And essentially, this EIP is kind of tiny. All it does is it defines a few more network packet types. One of them is announcing a transaction, so that the same way that we can announce a block by hash, we can announce a set of transactions by hashes. It introduces a retrieval request so that if I know of transactions by hash but I don't have them, then I can retrieve them. And of course, the reply that, okay, here's the transaction. And my hunch is that this should cut down the global bandwidth usage of Ethereum by at least an order of magnitude. And yeah, kind of that's the EIP. The EIP has some minor details in it. Feel free to read it. I don't really want to go into those. But yeah, our question is whether does anybody oppose this? I know that we've talked with Nethermind. They like it. As far as I know, the Trinity team also responded. They made some suggestions which we incorporated. The question is does anyone else feel that this DIP should be changed a bit, or can we go ahead with deploying something like this on the network?
I'm strongly in favor of this one. Very, very good improvement.
Yeah, so to clarify, this is not a hard fork, and if there's no opposition, we will probably merge this in the coming week.
So just another quick note: if you look at the EIPA, we also linked in the pull request that implements this in Geth, and that pull request is huge. I mean, it's 1,000 or almost 2,000 lines of code. And I think it's important to highlight that supporting this EIP takes maybe about 20 lines of code. So the rest of the 1,000 plus lines is all about the plethora of optimizations that this EIP enables us, so that we can essentially cut down so many things that previously we had to keep.
I have one question. So is this is going to be backwards compatible, which means that if somebody doesn't support that, they will still be falling back to 60, like E64.
Yeah. So this is the same way as with E64. So all nodes, so Def peer-to-peer protocol supports running arbitrarily many versions of these sub-protocols on top of one another. And for example, Parity didn't implement yet E64. I'm not sure whether they will, but we have absolutely no plans of dropping support for either 63 or 64.
Okay, so fine. So it means that it could be implemented like gradually.
Yeah, of course. Yeah. No, so that's a nice thing, that as long as the spec is approved, so that the client developers agree that this is the direction we want to take, it's completely fine for each client to implement it and roll it out whenever they find the time.
Is there a place where we're keeping track of which ETH protocols each client supports, and then which ones to deprecate at some point if all of them agree, oh yeah, we actually are like on the last three, so we can forget the last one for anyone or something like that?
Well, not really. So I think it's so probably the reason we don't have it is that ETH63 was spec'd out when Ethereum launched. So I mean, it's you could assume that everybody implements ETH63 because that was the first official version. And then the first upgrade to this was made by us last year in November. So this is the first time when we actually made an upgrade. As for old protocols, I know that before 63, there was 61 and 62, but 61 was only implemented by Geth and C++, but since CPP Ethereum is not the biggest rage now, I think they implemented 62 and 63. So eventually we just dropped support for the older ones. So nobody was running ETH 61 and 62 anymore, so we just nuked it out of Geth. And I think the same thing can be done again if Parity ever upgrades to 64, 65, etc. then well, we have the boot nodes, which are constantly, we are logging exactly what protocols and what protocol messages are coming and going. So if none of the boot nodes log old protocol messages anymore, that's a pretty strong signal that that protocol already died out of the network.
So does anyone have objections to this? Otherwise, should we just move it to last call? Okay,
Yeah, why not?
great. So let's move this to, oh, sorry, go ahead.
Was the EIP merged as a draft yet?
Let me check.
I don't think so.
No. So we should probably merge it as a draft and then merge it, move it to last call at the same time. Is that possible?
I don't know, Alex.
Yeah, I think the EIP one is kind of underspecified in regards to this. There was only, yeah, I think there's no strict rule. I guess it's really only relating to the people on this call, and since everybody seems to be in agreement, I guess it should be fine.
Yeah. And to be clear, I think it should go to last call because, like we discussed a couple calls ago, that'll trigger a bunch of alerts for different peoples, and we can get broader community review on it, which I think probably won't happen if we just go to draft.
Is there anything from the Besu, you guys, or thoughts on this?
Dano?
It seems reasonable. We just need to get time scheduled to implement it. It doesn't look too terribly difficult.
Okay, so let's move this one to last call and obviously merge it in as we do that. Next one on the agenda was EIP 2348, which is about validated EVM contracts. I think that one is Dano's. Yes.
Yeah, sorry about that. Sorry about being late. I slept in. I didn't sleep in too long though. 2348. So since the last time this came in, I added a couple of changes to address some of the concerns that that were brought up by Martin and Carl. The first major change that I added was I added an extra rule in the validation. I pointed out that there's like a code segment that exists before the begin data and after the begin data. And as part of the validation, I limited the size of that to the contract size that can be stored on the blockchain. There's a couple of ways you can overcome this blockchain storage limit. You can do it in the NIC code, although I don't know how you can make it terribly useful because you're still limited on building in memory. And the second way we're actually seeing on the network is where you can pass it in as part of the transaction. We're already seeing roll-ups that are in excess of 32K and now up to 128K. So the data, those are mostly data, storing all of the information about the particular ZK rollup that they're doing to get those stored by Ernst & Young. So that's the first major change that I put in. The second one that I put in was to specify the particulars of the header. There was a previous recommendation that had EF01 as the header, and I adapted that, and it's EF EVM, the hex EF, which is the I with two dots under old ASCII. And to clarify that when you start running a validated contract, you start at PC equals 4 to keep all the XD code copies, relative to the 0 index. Those are the two major revisions that I did to try and address some of the concerns that I had heard. And I want to know at this point, are there other concerns if people reviewed this? What other adjustments might need to be looked into?
Yeah, so could you just clarify? So what is the fix, or rather, does this validation run on init code?
The validation does not run on any code.
Okay.
In order for the validation to run, you must have the header in the code, the 0xEF065, 0x76, 0x60. Those are the first 4 bytes of your code. And It requires a versioning spec. The blockchain must turn on version code, so it must be a version 1 account that's running it. If either of those aren't true, the validation does not run.
Okay, so my question then is it possible for me to trigger the validation to run on init code when they will create?
So that would be no right now. The instruction 0xEF is not a valid EVM instruction right now. So if you tried to load a contract with the validation, it would happily store it in code. Come time to execute, you'd quickly fail out when the first PC hits and sees an invalid instruction under the old sets of instructions. And so if you try and put a validated contract out there, you wouldn't get anything out of it.
No, I mean in this EAP.
In the seat.
Right. If we this.
Mm-hmm.
On init code or not?
Yes. And so it would validate only the first 32 kilobytes of code. And if it hits the 1 byte past 32, it'll throw an invalid code exception.
I see. So that would be an added validation then,
right.
Which does not exist today.
Right. Okay. I added another step in there as you're validating the code. Once you get past 32 megabytes and you haven't, not 33 megabytes, 32 kilobytes or whatever the contract limit is. It's actually 24.
Or 24K actually.
Yeah. Once you get past that, stop validating. It's not valid anymore because you really can't figure out where the begin data, because that begin data byte could be hiding inside a multi-byte instruction like a push. Any other questions? Any other concerns about this particular adjustment?
So what is the next step here?
If we're going by Martin's model, at this point, it would be eligible for inclusion, but it's not committed, so someone would need to implement it. And the most important step of the implementation is writing the reference tests. And as champion, I think that would fall on me to get it implemented and get the reference tests written, and then it comes back again once the reference tests and everyone can poke out of the security before it's generally recommended for all clients to implement it.
Quick question. If I understand it correctly, this assumes a new account version.
That is in the EIP, yes. That only triggers on the new account version. It requires the 1702 account version.
That's so much for having only 2 account versions ever.
That would be nice.
Yeah, you missed that part of the conversation that opened the first, I think, 30 minutes of the call when we were discussing on gas. There's a proposal around just having the account versioning only activate once when we do on gas. Yeah, so that's.
So I would love it if we could limit it to 2. This doesn't require 3 or 4. We could combine this whatever on gas is coming in. And if it's the on gas proposal that I saw before, I mean, they're talking about changing call from 6 arguments to 5 arguments or 7 arguments to 6 arguments. So you're going to need something like a header in the code to say, by the way, this is the new version of the code.
Got it. So it's. Go ahead, Martin.
Yeah, I was gonna. So I'm reading through the motivation, and so the second motivation is that we don't need to do a jump test validation, and the third one is to improve JIT, and those are practical in my opinion. Although I think the second one, I don't think there's a big improvement because it's pretty fast to do validation. But the first motivation about the evolvable EVM, it strikes me as kind of vague. And could you elaborate a bit on the practical impact for that motivation?
Okay, so the biggest thing that this would unlock is the ability to add new multi-byte instructions. The only multi-byte instructions we have right now are the push series of instructions, where there's a push and then a bunch of data that's part of the byte stream. And the reason why we need to validate the code before we can add new multiple byte push instructions is for jump tests. For example, if you had an old invalid instruction that became a multi-byte, and then you put the jump test inside of what that multi-byte would consume, all of a sudden you have created a new thing that is invalid to be jumped into. Code that was once valid is suddenly now invalid because you added a new instruction um, where there was a bunch of noise data that you could have jumped into, and then now you can't. That was one of the test cases that was brought up in response to 650, I believe it was, Greg's old standard. That was one of the test cases that was critical and was stopping it from going forward. So by putting the validation in, we can make sure that in the code segment that invalid codes aren't there. So we don't have the situation of, like say an error in the transcription suddenly making the code unusable. So if you can add multi-byte instructions later, you don't have to worry about going back for all the validated contracts and say, oh, by the way, the jump test is going to be hidden here.
I'm not sure about it because it feels like simply validating that in the same pass as we are doing now in the gem test validation. It's much simpler and much less complex than all this suggestion with the validation.
I'm sorry, my internet foggy.
I think it seems to be much more complex than trying to just improve jump test.
But how do we keep the old deployed contracts still working is my concern. We want to keep what's working as is under the expected rules and not all of a sudden invalidate what's on there. Because we can't just say, well, don't do this, because of the time we announce it, the time we deploy it, we should expect people will deploy broken contracts to try and exploit it.
And what is the current basically require? Where is the multi-byte opcodes are required currently? I mean,
push. It's 40 to 5F.
Okay, so but I assume that the EIP probably talks about adding more multi-byte instructions.
Yeah, those not initially. This is the first step because when they tried to put it all in with the EVM Evolution 650,
okay.
It got it was just too much at once to handle.
Right.
So this is getting there by multiple steps.
I understand. Okay.
When we first identify the actual EIPs that will need it, and when we agree that they'll be needed, then we will have the ready proposal on how to do that.
But this also means, I mean, not only this also means that it will be easier to add new opcodes, right?
Right. It would be easy to add not multi-byte, single bytes. It'd be easier to add opcodes and make sure that they aren't just sitting dormant in other code.
And does this one also enforce static jumps somehow or not? Yeah.
Does it?
It does, yes. I think.
It can.
I think it's part of the, there's a heading for it, static jump validations.
Yeah, I don't think you can implement Solidity functions without.
Oh, there it is. Yeah. Yeah, 615 was totally ruined by this issue. Alex, you had an EIP which also was ruined by this issue, didn't you? Is Alex there?
Swap N.
Yeah. Alex isn't answering, but it was his proposal.
Yeah, but I believe it was unlimited swap, and there was another one going along with it that they were going down the paired pushes rather than just doing the multi-byte instruction.
But in general, allowing undefined opcodes to be scattered through our files is just wrong.
Yeah, definitely. If Greg will be saying this is needed and looks fine, and Dana, you've also done a lot of research on this one, then it seems like enough of recommendation for me.
Yeah, I would like to have heard Way's thought about this one, because he's also been doing a lot of championing about different types of. I mean, he proposed 3 separate versions of versioning, but yeah, I don't have anything against it to say right now. Really.
And this is one general thought I had is that it's the usually, and this is something that I would like to address with the semantics, is that usually it's very difficult to from the IP format I guess we're using now. It's usually pretty difficult to estimate the semantical impact of this change onto because as we know there will be a lot of interesting edge cases. So I would like to spend more time looking at this somehow, but so I sort of caught me unawares this particular thing, but I don't. Yeah, so it's very interesting. But I also I'm wondering how this is going to play together with the with the account versioning and ungas as well, and whether this particular whether the path that we're going into, because this is actually just one first step in the path, right? Whether this path entails us to have a multiple versions introduced, because it does it, and then this sort of it interplays with what I just said in the beginning of the call, that okay, we want to have only 2 versions ever, or maybe we'll have only 3 versions ever. So yeah.
So it enables multiple models. We have versions where there's a version 0 and then version 1 is version 0 plus these opcodes. That's the particular feature that I would prefer, to where we don't really run 2 full versions of the EVM. If you run it in validated mode, it just unlocks more operations. You still have the old ones at your disposal.
So what I would say is that we probably should identify. So the advantage of of bundling everything together, of course, is that you only have ever 2 versions. But obviously, the disadvantage is that you basically end up with a huge release, with a huge hard fork, which you don't want. So maybe what we could try to do is that figure out the path where we could have still 2 versions, but we can add stuff to it. So what does the obviously it will need to be a proper order of adding things. Like, what is the first thing need to be added? What could be added next without ruining that version? I mean, like the sort of backwards compatible change of that version. So it looks like this one, for example, could probably going to be one of the first, because it actually establishes a better platform for backwards compatible addition of new stuff. I would say, but I would look at it at least from this perspective.
So if we're going to take anything out, it would have to be. So if we're going to take out the gas operation, if we're going to change what the call operations do, it has to be done in the first step.
All right.
Dan, do you have a sense of if you want to pursue this for like the upcoming Berlin, or kind of later in the time schedule? For some context, the Wei had said that he wants to move everything post Berlin, including account versioning.
I tend to agree with it. I think it's ambitious for me to get a prototype written and then all the other clients to implement it by Berlin. I think that's quite ambitious. I'm willing to go along if other people think it has to be done, but I think moving it out to London would be wise.
Cool.
Okay. Any more comments on this? If not, I think we're moving to another one of Dano's eats, 2456, the time-based upgrade transitions. And I think, so Jason.
Is Jason here?
No, I don't think he's here, but he had a comment on the agenda. I'll just like read it for people watching. But he says he's kind of negative about an implementation that requires looking up a bunch of historical headers to decide which VM version applies to a given header. And to be clear, this is related to the time-based upgrade transition, so using a timestamp along with a block rather than just a block like we do now.
Yeah, and the one thing that Jason recommended to change that might not get us to not have to do this complex two-phase firing is if we just require that all OMRs have to have a timestamp equal to or less than the header they're included in. So the question there is, what would that impact network-wise, and would that adjust the problems where we can just fire on a specific time? If those things work, I'm fine jumping there. Martin, you said something?
Yeah, I'm wondering why it matters, the OMR.
So if there's an OMR that is, so let's say that the block is before the transition and the OMR is after the transition, and there are some really expensive changes, like a change to a proof of work algorithm was an example given. It gets kind of choppy at that point. So we want to make, but then because when you validate, then you just validate the header.
No, it doesn't. But you already have it split up into first.
Yep.
Into two phases, right? So the OMR can't reside. The OMR parent can't be before the first checkpoint.
So I was advocating Jason's position that we get rid of the 2-point checkpointing, that we just transition at a particular time.
Oh, did you update the EAP?
No, I didn't update the EAP. This is Jason Carver's counter proposal that he didn't formalize in an EAP, but this is the thing he would rather see. And if you know, honestly, it's a bit simpler, and if there's no network problems, it does seem like a more reasonable route and easier to code. But I thought there was issues with just setting a hard fork on a specific time.
What issues do you expect from the OMR not being on the same fork? It's the OMR validation is just a simple header validation, so usually it's not a big problem.
But what if the hard fork includes changes to the header validations?
I think then we'll just apply the old style validation to that particular OMR. We've done it in the past, like we had OMRs on the different forks and we are validating them because you had actually the DAO fork required different header validation.
And what if people start generating OMRs far in the future? That's another concern.
So what are we discussing here? Are we discussing your EAP or are we discussing
Jason's counter proposal? Even though he's not here, I want to get opinion on it.
Could you briefly recap that again, because my head was on your EAP?
So Jason's counter proposal is just, instead of looking back at blocks to see if it's been activated, we simply branch on a time. And the one change to the protocol to solve some of the concerns that were voiced was that they require that OMRs be at or prior to the time in the block being validated.
So this wouldn't require the.
James,
I think it's okay to prevent the far in the future OMRs, but the requirement for them to be not later is a bit too strict because at the given block would like to allow them to include the OMRs. So I would just, we may agree to that, just not set it to be equal or less, just add 10 seconds, 15 seconds, whatever the block time is on the given network.
I think actually it would be a good idea, even in separate, just in itself, to have that rule on OMRs that they must be older than the now block.
Or the 15-minute skew that we currently give clients to receive blocks. but it's easier to validate now.
Yeah. There's no reason for an Omer to be in the future. There's no legitimate reason. Prove me wrong.
It can be if you have the time desynchronized between two different miners, and one miner is just 1 second later, and it will just broadcast the block, and the other miner will pick it up, and will just milliseconds after it will find its own block. It will publish with that Homer. So it will be still valid because obviously consensus is one part of agreeing on what the actual time is. So,
but if yeah, I mean that Omer could be picked up in the next block. Yeah, so maybe we should have some leeway there.
Yeah, because all the clients right now, we get a 15-second in the future, 10 and 15 in the future of any block we see from now. It's not like Bitcoin where they get 2 hours of skew. I think our clients give only 15 seconds. So if we codify that in the honor rule, then it's something we can point to pretty reasonably as well as say why this is why the clients pick this magic number too.
I remember previous research saying that it takes about 7 seconds for something to be propagated.
So one thing I don't like about pure timestamp solution is that it's impossible. You need to do binary search to figure out what block we forked on. If you're, for example, a light client or doing a fast sync or something.
Right. And this is the sort of thing where during the fork, it'd be a bit choppy, but after the fork, you can identify it, 2 weeks after when people update their clients, and you can put in a suggested start search point. So the binary search could just be to the block before and the block after.
I'm still trying to get my head around the differences between what the having the time locked, like saying at a certain block, then this point in the future will fork versus this version.
Yeah.
And could we
how about we table this until Jason can come on and discuss it, or we get more discussion in the forums? I'm happy to table it.
Yeah, I was gonna say if it's possible to like get some of those arguments on like the ETH Magicians thread, I think that would be valuable as well. Like it seems like there's a lot of edge cases and whatnot to think through, and getting more eyes on that is probably a good thing to do.
Yeah, Jason posted it there on my request, so I think we should move it to the forum at this point. I was a bit concerned last week when there was no objections. It's like, it can't be this easy. And it wasn't.
Cool. So yeah, let's move that conversation back to ETH Magicians. Next EAP up was 1962. I saw there was an update given on that on the agenda, but I don't know if there was more that people wanted to discuss on the call. So I put it there just in case.
Well, I have placed all the progress because it's basically just updates and optimizations into the written form to the GitHub. So if there are no direct questions, I can just save people's time on this and you can continue.
So I do have a question. You mentioned that there's a Go version that, at least for now, uses the 64-bit assembly, Go assembly.
Yes, but I'm not the one who writes it. I linked the person who writes it, and I think Said should be here on the call. Let me check the.
Nope.
Well, at least he wanted to attend it or at least listen to it. Maybe he listens through the YouTube channel. But we just chat on Telegram, and he's an author. I will add the link to his work. I actually forgot to link to the repo, but it's kind of more or less pure assembly, and for now it will not be as a platform compatible. There is an idea how you can still do it in Go without templates and generics. by using kind of code generation in a very trivial form, basically make like 12 copies of the same file with different constants. But it we will not try it until at least this version is fuzzy tested is and as feature complete as other two.
Yeah, I guess that was mostly my concern too. That I mean, it's nice if somebody ported over to Go. I'm just curious about how stable it is and how reliable it is, because so if it goes down to assembly, I mean, I know Go's assembly is a bit more simplified, but still, if it is assembly optimized, then that's probably something that we cannot meaningfully review. I mean, I barely understand assembly. Maybe I could make heads or tails of it. I can definitely not review it or validate it that it actually does what it's supposed to do.
Well, assembly parts there is only very basic arithmetic. So like how you do the multiplication plus modular reduction of two large numbers. Everything else is normal code which you can read and which uses more or less the same optimizations which I have in Rust, plus minus some specifics of Go in terms of like no pre-allocate some variables, reuse them, and no garbage collection, for example, like kind of to reduce the garbage collection. But other than this, yes, it's not yet portable. And but for now, all the fuzzing errors, which I think Said encountered, were in parsing of the binary interface rather than in arithmetic. We tried few test vectors and had an agreement on those at least.
But yeah, if you have a link to the actual thing, then I would really appreciate it.
Yeah, sure. I mentioned it and forgot to link it.
I have an extra question. Alex, can you hear me?
Yeah.
Hello. Yeah, great. I have an extra question. Is this the CIP, the codes you're going to give to the various implement? Is it going to be independently audited by an external auditing company or another independent team from the matter? Is it planned?
I didn't plan to do any external audits. The best thing I could hope is to have independent implementations in more than one programming language and agreement between them in fuzzy testing. More or less, a spec is it's trivial in terms of as soon as you pick particular formulas from particular papers and all those actually compiled together and placed in one PDF document, you cannot like implement it different ways, I would say. So
okay.
as a short answer, I didn't plan to try to make an external audit, and even trying to find someone who would agree to do this would be very non-trivial and most likely time-consuming and expensive. So for now, we rely on, at least I rely on the fact that there are a few implementations done by different people, and which use different, even like different approaches how you would implement it in different languages. And as soon as they all coincide on same output data, on the same input data, and on some set of predefined test vectors, they also coincide on a solid results, like kind of testing the bilinearity of pairings. I would say this is it is already a very good start.
Okay, thanks for that.
Oh yeah, sure.
Any other questions, comments on 1962? Okay. Next one on the list was 1559. I think Trent, you posted a comment about that. I don't know if you had an update to give or if anyone else has an update or comments about it.
No, I didn't have a specific comment. I was hoping somebody from the implementer team would be here, but it seems like there's nobody here currently.
Okay, yeah, I know we had a discussion about it a couple calls ago. I'm not sure what the status is with that one at this point.
I do have an update on thinking about the timing of deployment for it.
Okay, yeah.
And as I've been reading more about it, one of the concerns is miner collusion, and them manipulating the fee in some way. And the more I've thought about it, the more I think that the order in which this should be done would be to have ProgPow be done first and then have EIP 1559 as a way to combat that, which I know is a giant can of worms, but that is where my thinking has been recently.
Can you expand on what you mean by manipulating or collusion by miners?
Yes. So if a bunch of miners wanted to get together and say, hey, let's lower the fee, let's increase our what miner tip we would allow, and then have the base fee slowly be chipped away down, like that would be an actual attack that they could do. And the reason it's hard to do now is you don't really gain a lot currently. And as far as it is difficult to coordinate among miners, but as ASICs as ASICs are harder to get, then there is this possibility that market power could be developed among them, and I mean that in the economic sense of they would be able to enact prices that a free market otherwise wouldn't allow. And the way to get rid of that would be to have it easier for people to get into mining and not have that be through there's two ways to get market power. There is you're either everyone, so you can choose, and that's monopoly, or the other one is you can gatekeep strong enough that the current participants don't have anyone that could come in and work underneath and provide a lower price.
Okay, interesting. I'll have to think more about that. Have you maybe you should add that to the magician's thread and see what the implementers think about that vector.
Well, it's already in the security considerations. It's the what to do. It's the what to do about that security consideration is where I've been thinking.
Gotcha.
Great. Any other comments, updates about 1559? Okay. So that's it for the EAPs to review. Did anyone else have an EAP they wanted to discuss? If not, the next thing was testing updates. Does anyone have testing updates? Okay, no testing updates. Then EIPIP meeting number 1. I think Hudson had a comment in there. I wasn't part of the meeting. I don't know if, no, Hudson did not have a comment, sorry. Yeah, did anyone want to comment about that?
Yeah, the next meeting is next Wednesday.
Okay.
Yeah, I can give a little brief about what the first meeting. The kickoff meeting was conducted on January 15th, and the participation strength was quite decent. The best part of the group was that about half of them have actually pushed or tried to push at least one EIP at one point of time. So the discussion was around the present concerns around the current EIP process. we discussed a few suggestions on how to improve, and that has been documented. I'm going to share the link of the document. For those who could not attend the meeting and are interested to know what we did in the video of those have been updated on the Ethereum cat herder GitHub. So we created a repository and we are going to maintain it for every forthcoming meetings with the video and the notes there. The next meeting is scheduled on 29th January at 1500 UTC. There is a Telegram group for EIP. It is not public for the spam bot reasons. So people who are interested, they can reach out to hudson@ethereum.org, or just drop a note at Ethereum Cat Herders GitHub that they are interested to join the Telegram group, and we'll take it from there. So yeah, that's it from the update side. If anybody has any question, I can answer that.
Okay. Thanks, Pooja, for the update. Next thing on the agenda was Peter, you had posted about an RPC spec issue. I don't know if you wanted to discuss this on the call or if you just wanted to put it up there for visibility.
Well, it's not, I don't know how much discuss it. I think it's something I think should be fixed. I put it on the call so that if somebody opposes it, they can voice it. Essentially, when you retrieve a block on the RPC APIs, if the block is the pending block, then the spec states that the number field in the results should be null. And for apart, so not just the number, but for example, the miner, the hash, and some other few fields. Now, obviously, the miner, it makes sense to leave it as null because there's no miner involved. Same goes for the hash, since you don't really know what the hash of the pending block will be, so it doesn't make any sense to return it. However, it also states that the number should be null, and I think that's actually wrong, because the same way that the pending block actually has a parent hash, which references a real block, if it has a parent, then we know specifically what the number of the pending block is. Of course, by the time it gets included, maybe there will be 3 other blocks and whatnot. So of course, you cannot rely on this block being final, but we know that this thing should have numbers something something. And furthermore, since transactions can access the number of the block that they are executed in, also means that transaction execution can depend on this number. So if we just say that, well, pending blocks don't have numbers, that's kind of a little white lie, because transactions executing inside do have access to that number. So I don't think we should hide it from the end user. So essentially, this was something that we fixed in the last Geth release. I mean, fixed it by turning it into null, and some people already started complaining that it broke one of their pools. And then we investigated and we kind of decided that although our latest release confirms to the spec, I think the spec should be fixed and we should revert that change. So is anyone opposed to actually including the block number of the pending block in the reply?
Awesome.
Okay. I'll take that as a no, and then I'll just update the spec, and I'll also we'll revert this change in Geth, so that we still continue, then we continue to return the block number.
Sounds good. And yeah, I guess it's also worth noting that on the agenda where you posted this, there were a couple of people that gave a thumbs up to it. So it seems, if there's no objections here as well, yeah, seems reasonable to go for it.
Not an objection, but a question. Are there any conformance suites for the JSON RPC calls? Should there be?
There are not. There should be, yes. I guess the problem with these conformance suites is that you need to actually set up a meaningful chain so that you can fire RPC requests against it. And you need something like that in a cross-client compatible way. There was way back, I think Fabian Forgesteller wrote one, but that was even before Frontier launched. So it just tested a few subset of the RPC calls. Originally, we bought
and then Bas wrote one, and then KCD3 wrote one.
Ah, okay. Apparently, there are lots of test suites that we don't use.
Yeah, because that goes on to the second question I had. Because I know, like, I guess Oasis is trying to spin up work with the OpenRPC stuff. Is this something that we should own, or should we encourage like the Oasis group that's spinning up to own it and run with it, and we fully adopt it? It's more of an open discussion question. I don't have an answer I'm looking for.
So me personally, I'm not a fan of OpenRPC because so I think OpenRPC OpenRPC is essentially kind of a clone of Swagger. Maybe there's a new name for it, OpenRest. I don't know what the name is, but essentially that specifying or specing RESTful calls, there's the standard for it, and that thing has been kind of embraced by a lot of industry players, big players, and it's been really pushed hard. So we can assume that Swagger is kind of a standard. However, with OpenRPC, well, OpenRPC positions itself as the spec for RPC, but really is just a team that put it together for Ethereum. So the reason I'm not a fan of it is because if it is specifically made for Ethereum, then and nobody else uses it, then it's not really a standard. So it's not really, I don't know. I just don't want to incorporate a standard that's actually not really a standard, but just another. I would much rather go down the path of creating a flexible test suite and somehow maintaining that.
Okay. Well, I mean, I wasn't meaning to open the can of worms about OpenRPC, just about should that Oasis standards group that some people are looking into forming, who would have jurisdiction over creating it and declaring it. But yeah, I don't really have an answer on that.
After going through the call, going through all the Arcore dev stuff, I think we have the recipe for doing it right, which is we have groups that are willing to dog food it and are working on it and have pain points, and that we can. It's almost like you're doing it in-house, but in-house is an in protocol. So as far as making a standard so we can make another standard, having a group of people go to another room and then decide, hey, this is how the standard should be, versus we have people that are using it and we can build it so they can use it better, and we know why they don't like it, so let's make it easier for them. Like that feedback mechanism feels like we have the recipe to make it work.
Cool.
Okay, and that's weird. I had some weird echo. So that was the last thing on the agenda. We don't have the notes from the previous call yet, so we can't really review the action items unless anybody remembers anything that was important that we should follow up on, or otherwise, if people have anything else they want to discuss in the last 4 minutes, we can do that. Okay, I guess one thing I would want to bring up, but probably for the next call 2 weeks from now, is it seems like we have a lot of stuff that's kind of in flight for Berlin, and then some stuff that's starting to shape up for London. So it might be good to have like an async discussion of, what could be ready to ship when, what's like how early or late are all of these proposals. I don't know if anybody else thinks that would be valuable.
Yeah, I would agree.
Cool. So yeah, maybe we can kind of have that as an action item for next call, but over the next 2 weeks to just try and follow up with the teams, and if you're the champion for an EAP, to try and get a feel for how far along things are, what's like a realistic timeline to get this done, and then based on that we can maybe see what can be bundled together, what should be standalone, and what are the dependencies across various initiatives. Cool. Is there anything else anyone wants to bring up? Otherwise, we get 3 minutes back. Okay. Well, yeah, thanks everybody. See you all in 2 weeks.
Thank you.
Thank you very much,
Bye.
everybody.
Yeah.
Bye-bye.
Thank you.
Thanks.
Thank you.